Hey everybody, we are going to start dose calculations this week. And if any of you have talked to some of the older students, you may be a little petrified. Don't be afraid because, first off, you guys are doing what is not quite as advanced as the other group, but you are going to do some of the same type of things. So we're going to talk about methods of dose calculation. There's more than one way to do dose calculations. And it's needed not only in pharmacy, but in nursing, if you're a med aide, if you're a doctor, if you're a pharmacist, if you're a physical therapist, occupational therapist, you all need to know about medications and medication dosages and how to calculate it. I'm going to teach you guys. It's probably not the quickest way, but it's the way to have the fewest errors. Once you get it down, it is the best way to have the fewest errors when it comes to calculating an amount of medication to give someone. It's really important. I'll tell you, go ahead and learn it now. That way, it'll be, if you're going to take my class next year, it'll be less difficult. If you're going to be Pharm Tech or whatever you're going to take, it will make it less difficult if you learn it now because we'll just add on that or expand on that next year. I want you guys, most of you have taken higher level math, algebra, geometry. Some of you may have even taken classes that have chemistry, physics, those kind of things in it. I want you to forget all of that math you know. Remember your add, subtract, multiply, and divide, and remember fractions and decimals. And that's how we're going to work. We're gonna talk about it, and then we're gonna work through some problems. This will be one of the times I actually record my class for you guys in-house so that you can hear some of the questions that they ask. I'm gonna record one of my smaller classes so that as they ask questions, it won't be such a bombardment of questions, but you'll still hear them asking questions to know. Or maybe you guys will have questions on top of that. So let's kind of get started, and we're going to do a little bit today, and y'all are going to have some information to look at on different conversions that are really important to remember. And because remember, I know on your state exams, your STAR exams, you always get a conversion table. You don't need to know that many, and you won't get a conversion table for this particular test. So there are things you're going to have to memorize, okay? Like how many milligrams are in a gram, how many micrograms are in a milligram, how many how many milligrams are in a grain. We're going to talk about those. Be sure that you're taking notes and you highlight these things in the information that I'm giving you, and you learn them because you will need them for your test, because you will not be allowed to use a conversion chart on your test unless you have some kind of modification or requirement for that. Okay, so let's get started. So our objective is to master the ability to identify information on a medication order to be able to calculate the desired dose. Because sometimes a doctor will write an order for a certain amount of a medication, but due to the way that we have the medication, maybe it's either in the pharmacy or what we have on hand. What we have on hand may be a different dose. So we have to figure out how to calculate and give the correct dose. Also, convert from the ordered dose to the desired dose. So the doctor may order something in grains, but we only have it in milligrams. So how to convert those things. Also, to calculate how much to dispense. So maybe we need to give how many pills or how many milliliters. And then to recognize common errors that can happen during calculation, and then calculate and estimate daily supply. So how many pills are they going to need to take in a whole day? Or how many milliliters are they going to take a whole day? Or how many milligrams are they going to take in the whole day? So what we're going to talk about in this unit is how to use information that you already know, add, subtract, multiply, and divide. Take that information and learn and how to use decimals and fractions work together, using that information to figure out how to calculate medication dosages. You're going to use basic math, information from a physician's order, from drug labels, and I'm going to show you guys some drug labels on down. You're going to have problems later that will just give you the drug label, and as opposed to what we have on hand. It'll give you the doctor's written order, and then it'll show you a drug label as what our supply or on hand is, and then you're going to figure that out. And then the methods of converting quantities from one unit of measure to another. So taking a milligram and turning it into a microgram, or a grain and turning it into a milligram. Those kind of things. Dose and dosages. So how to calculate a medication dose, you've got to know what the desired dose is. So that's what your doctor's order. That's the amount of drug to be dispensed at a single time. So the desired dose. How much do I need to give? Its unit of measure, do I need to give it in milligrams, micrograms? And know that if the doctor orders grams and we have milligrams, we've got to convert that. We've got to, what's ordered has to be the same as what we get when we figure our calculation. We have to convert a lot. Okay, the dosage ordered, that's what the doctor says to give. How much and how often? So Dr. Cuttrell orders 25 milligrams of hydrochlorothiazide BID, or twice a day. That's a doctor's order. That's the dose ordered. It's going to be in milligrams, micrograms. So remember, whatever our dosage is, our ordered dose has to be the same as our unit dose. And unit dose is what we have on hand. Dose on hand is the amount of drug contained within the unit dose. So that's that dose. So sometimes it's referred to as a unit dose. Sometimes it's referred to as supply on hand or dose on hand. So if a medication has 25 micrograms per tablet, then we have if a medication has 250 milligrams of a drug per tablet, then the dose on hand is 250 milligrams per tablet. Or 250 milligrams, that's our dose on hand. The unit of measure for a desired dose must be the same as the unit of measure for the dose on hand for whatever we're going to dispense. So if they're not, we have to calculate that. We have to make sure before we dispense a drug that it is the correct ordered dose. And we calculate it by converting from one unit of measure to the other. And we always want to start with what is actually ordered. So how do we calculate it? Before calculating the amount dispensed, you first have to determine the desired dose. So the dose ordered is not always written in the same units found on the drug label. So your unit dose is not always the same as what the doctor orders. That would be if we had an order for Lasix, 20 milligrams, 1 PO BID twice a day, 1 tablet by mouth twice a day. But what our unit dose is 40 milligrams per tablet. We would have to figure out how much we would need to give. How would we need to administer it? When we talk about tablets and suppositories, pills and suppositories, they have to be scored, which means they have to have a line down. They have to be scored before we can break that pill apart. If it is not scored, we cannot break that medication into smaller doses. Okay? So remember that. Tablets and suppositories must be scored or have a line down them before we can break them apart. You must convert the dosage ordered into the desired dose so that they have the same unit of measure. There are three ways to calculate it. Fraction proportion, ratio proportion, and dimensional analysis. We are going to use dimensional analysis. It is the way, and you're going to see the others, but dimensional analysis is how I expect you to work out the problems. It's what you're going to see me do. It's what you're going to see students in my class do that are in my room every day. And it's what you would see in nursing school and schools of pharmacy and schools of medicine, because it is the best way to not make a mistake. It will show you will mark out every unit of measure except for what the question is asking. They will all give you the same result. And And it says use the method you like. Well, we're going to use the method Miss Cruz likes, and that's dimensional analysis. Once you get that down, you can use fraction proportion or ratio proportion, but for now, we are going to use dimensional analysis. Once you identify your favorite method, then you want to be sure that you use it over and over. But for now, we are going to use dimensional analysis. Once you get into nursing school, or once you get into pharmacy school or medical school, I'm going to tell you, nursing school, they teach you dimensional analysis. But once you get real comfortable with that, you can use one of the other forms. What you do not want to do is flip back and forth in the same problem. You want to pick one and stick with it till you figure out whatever the desired result is. Okay, so we're going to look at the fraction proportion method real quick. So what you do is you write the conversion factor with units and convert the numerator units with the denominator units. So you're going to set it up just like a fraction. And then you're going to solve for the unknown. You have you set the two fractions up for ratio and as a proportion. You cancel out the units, cross multiply, and solve for the unknown value. That's what you guys are used to doing in a lot of your algebra, but we're not doing that here. Part of your grade for doing these problems will be actually working them out using dimensional analysis. So this is an example. Dose ordered 0.2 milligrams once a day. What you have on hand is a 100 microgram tablet. Find the desired dose. The desired dose is 200 micrograms. So in a fraction proportion, the units from the fraction can be canceled only when they are the same. Otherwise, you have to do conversions in your head. And that's why I don't like this method when you're starting to learn, is because it doesn't give you space to convert your units so you can see that you're converting them appropriately. Proportion method, and that's where you have A over B. So it's similar, and C over D. A over B has a conversion, and so you're going to write it A to B equals C to D. Once again, this can be really confusing. Let's see if it gives you an example. Practice by determining the desired dose. Order reads aspirin grain 5 PO daily. Drug is labeled 320 milligrams. Find the desired dose. The desired dose is 325 milligrams. So once again, you have to convert it in your head. Using dimensional analysis, you are able to convert in the steps of the problem that you're working. So be sure that we do that. Now, we're going to stop here with recording today. I know this is kind of a short lecture, but I'm going to give you some reading material to do. Be sure that you make flashcards. It is part of your assignment to show those flashcards where 1 gram equals 100 milligrams, 1 gram equals 1,000 milligrams, 1 milligram equals 1,000 micrograms, 60 grains equals a grain, 60 milligrams equals a grain. You're going to use the tables that are going to be given to you to be sure that you have some flashcards to help you remember. All right, we're going to start, and we will pick up with dimensional analysis tomorrow, and we will start working some problems. All right, guys, have a wonderful day. Thank you.